Hi, this is VBL. In this video, you are going to learn saturable property of an op-amp. For that, I have taken an op-amp symbol here, which takes inverting input V1, non-inverting input V2, and dual power supply plus V and minus V, and the output voltage is represented by V0. V0 is the output voltage, which will be equals to open loop gain A multiplied by the difference between the input voltages, that is V2 minus V1. Now you know that what is a practical op-amp, which will be offers 2 into 10 to the power of 5. This is the open loop gain we know. So that if I apply that here by taking two cases. Case 1 is when V2 is equal to or V2 is greater than V1. On that time, what happens to this difference? Difference will be a positive, right? So I can write V0 is equal to 2 into 10 to the power of 5 into V2 minus V1. For example, I take 5 minus 1. So 5 minus 4 I will take. So 5 minus 4 means what happens? This will be equals to 1 and then 1 multiplied by 2 into 10 to the power of 5. So what is the value? Value is a positive value, which is equal to 2 lakhs. 2 lakhs of volts. Okay, this is the first case. Second case is when V2 is less than V1. V2 is less than V1. On that time, what happens? V0 is equal to 2 into 10 to the power of 5. This is 4 minus 5. Then this will be minus 1 multiplied with the gain, open loop gain, 2 into 10 to the power of 5. So what is the answer? This is equal to minus 2 lakhs. Okay, minus 2 lakhs of volts. Do you think we will be getting 2 lakhs of volts at the output? No. Why? Because here we have got a power supply which will be limiting the output voltage. For example, if I take the power supply voltage as plus or minus 15 volts, okay, the value of power supply is equal to plus or minus 15 volts. Ideally, I can say your output, which will not reach 2 lakhs volts, it will be limited by this 15 volts. In practical condition, it will be like plus or minus volts, which will be equals to power supply voltage is equal to plus or minus the exact value minus of plus or minus 1 volt. That means you will be getting output voltage which will be equals to plus or minus 14 volts. This 1 volt less happens because of the internal circuitry of the op-amp. So let us write the output waveform. Let's take Vd is equal to V2 minus V1. In the first case, we got the difference between V2 minus V1 as 1 volt, and then in the second case I have got the difference as minus 1 volt. Depending on that, I have written a sinusoidal wave here. Okay, so the amplitude is between plus 1 to minus 1. Next, I want to have a output for this input. So let's see here. V2 is greater than V1 means V0 is equal to 2 lakhs of volts, right? So how I will be getting that in the waveform? Let's see. See here, the output here we will be getting by multiplying the input value into the gain of the op-amp, okay, open loop gain of the op-amp. So the product of that value will be increasing as this input increases, okay. So it will be increasing till this power supply voltage, that is, for example, 15 volts ideally. If I am giving power supply voltage as 15 volts, then ideally it will be reaching to plus 15 volts. After that, what happens? It cannot have further increase in voltage because the supply is itself 15 volts. Beyond that, you won't get. So for that, what happens? It will be saturated, okay, till the product of this input and the gain which falls below this 15 volts, till that it will be saturated. When it falls below 15 volts, then it starts decreasing like this. Did you get this? When the input is increasing, the output also increases up to the power supply value. After that, it will get saturated, and then the input and the gain product falls below the 15 volts, then the output will be decreasing to 0. So this happens during this case, V2 is greater than V1 case. Okay. Then during the second case, V2 less than V1. So on that time what you have got? Minus 2 lakhs of volts. This cannot be achieved at the output because the negative power supply which will be equals to minus 15 volts. So what happens? Your product of input and the gain which will be like this. It will be going till this minus 15 volts. After that what happens? It gets saturated. For example, I just write here like this and it will get saturated. When the input and gain product that will be falls below this minus 15 volts, what happens? You will be getting a signal like this. It will reach 0. So I can write when V2 is greater, you will be getting positive saturation. When V1 is greater, then you will be getting negative saturation. So this property we call it as saturable property of an op-amp. From this analysis you got to know that when you are not controlling the gain, then you will be missing some of the data in the positive cycle and also negative cycle. So that you need to have a control over gain factor. That can be done by using the feedback concept. Can we use this saturable property for any applications? Yes, we can use this saturable property of op-amp for comparing two values. V2 is greater than V1, output value is positive value. And when V2 is less than V1, then output is negative value. So that what we can say, by looking at the output cycle, we can say that whether V2 is greater or V1 is greater. I'll just check at the output terminal. If the output signal is a positive saturated value, then I can say V2 is greater. If the output cycle or output end we can observe a negative saturated cycle, means we can say that V1 is greater. By having this concept, we can say that saturable property of op-amp can be used as a comparator.
Hope you like this video. Kindly like, share, subscribe for more videos and press bell icon to get upload notification. And don't forget to comment your topic of interest in the comment section. Thank you.